Hi guys, welcome to this video. This is going to be a tutorial or kind of like a story on how I modeled this Nintendo Switch Pro controller in SolidWorks. I did this as an exercise to improve my surfacing skills, and I'm using SolidWorks 2020, but the techniques are kind of applicable to all general CAD software that uses NURBS surfaces. So yeah, just a bit of kind of groundwork on what I was hoping to achieve with this. I wanted to achieve good quality surfaces, which you can kind of evaluate in SolidWorks using two main tools. The first being the zebra stripes. So these zebra stripes more or less represent how light reflects off surfaces and gives an idea of the transition between two surfaces. So in this case, as you can see here, if we have the zebra stripes that are running in the same direction and there's no obvious kind of discontinuity between them, that indicates that there's like a good tangent transition between the surface. This model isn't perfect, and I will go through that as I'm going through this video, but areas where there's like a bit of wobbling, let me just find a good area. Yeah, so kind of here you can see there's a bit of wobble as the zebra stripes go around these kind of connection areas. That indicates that the surface isn't, like the best it can be, but this is okay. I was happy with this, and I'll actually go through some models I started with that weren't as good to give you a better understanding. Also, the curvature tool, kind of allows you to look at the curvature and transition between different surfaces. So generally you want sort of smooth transition between the colors. There are some inconsistencies here, which I don't think is actually a big deal. I think that's just kind of like SolidWorks resolution on this curvature plot. But yeah, I wanted to make sure that I was making good quality surfaces, and this could be a manufacturable file. So if you're interested in this model, please visit my website, mdesigns, www.mdesigns.space, and you can purchase it for a small fee and support my work. It's intended to be used as an educational tool, so you can go through the feature tree and hopefully pick up a few tips and tricks. And also just quickly, for anyone that's not familiar, here are a couple photos of a Nintendo Switch controller, just to have an idea of what this looks like in the real world. So jumping into it, I'm just going to go to the first model I started with many months ago. This sort of looks okay at first glance, but if I turn on the evaluation tools, the zebra stripes, we can see they don't flow nicely between the surface transitions. On this one, for example, we can see that the zebra stripes are running in one direction, and then the next surface they kind of like bend 90 degrees. So that wouldn't look nice if it was manufactured from this file. The light wouldn't reflect off it in a nice way, and with your fingers you would also feel that it's not a smooth transition between the surfaces. Also down here, I was just modeling this incorrectly and had a discontinuity point in the surface. So I'll kind of, go through this very quickly. Just rolling my feature tree up to the start of this first model. I actually started with some photos that I just took off my phone of the controller that I own. And I was seeing if, I arranged these as isometric photos, if I could model the controller this way, and ended up having some problems. It's basically just a bit too much curvature and like discrete form in here to capture it off photos alone. But how I started was with some kind of construction lines, and generally with a product that is symmetric like this, you want to model half first and then mirror it over later on. So there I just built a construction surface, and for now I'm just going to hide these photos so you can more easily see some of these sketches that I'm referring to. Okay, so one of the first major surfaces I built using a series of 3D sketches. So already a few problems here, which I learnt later on. You want to avoid using 3D sketches to build surfaces as much as possible, just because they're very tricky to manipulate and update. You can, manipulate the splines in three-dimensional space, and yeah, it's just much easier and more controllable if you can stick to 2D sketches to build your surfaces. And also this surface, it's just trying to do too much in a single feature. I'm attempting to build this whole kind of flat section of the top face of the controller, plus trying to do like a blend transition in one go. And it might look okay here, but setting myself up for more problems as I go. So then the top surface of the handle I also tried to build in one go, and was using some 3D sketches for the edges and also some kind of cross-sectional reference sketches. And when you try to make these very large complex surfaces in one feature, you just can't get the control or the design intent that you are hoping for. As I can see, if I move this around, that this drops off very sharply, the curvature of this surface. But then if I go in and try change one of the guiding curves, then it throws off some other things. So there's just too much going on, and SolidWorks can't really figure out what you want to do. So more or less, that was the approach I was taking with this model, building things in large chunks. But when you have something that has as much kind of detail and discrete form as this controller, you have to break it down into more kind of manageable steps. But yeah, more or less, that was kind of the incorrect approach. And no matter what I was doing to try update this stuff, maybe I would update some of these curves and get a better overall form, but then the transition between the surfaces wasn't nice. So yeah, I put this project on the back burner, went away and learned a little bit more about surfacing, and yeah, eventually got on the path to the model I was happy with. So going to the start of this future, or the latest model, I figured, I had to start with some kind of 3D scan. I couldn't just go off the photos alone. I think in my mind, I was thinking, oh, this is kind of cheating if I'm going off 3D scan, but really to try replicate this with any kind of accuracy, this is what's needed. And I've heard that in the automotive world, they'll often start with, a physical clay model of a car that will then be scanned and brought into CAD, and the industrial designers and engineers will work off that. I don't think that would have happened with, this kind of game controller, but the industrial designer looking at this obviously wasn't trying to replicate something that already existed. So they had a bit of liberty to, play around in the CAD and figure it out as they went. In this case, where I'm trying to get a realistic model, you kind of need to start with the scan. And just quickly comparing the scan to my final model, the scan is represented in the light gray here. And it's a reasonable match. I wasn't going for, perfect accuracy, and you're never going to achieve that. But yeah, just quickly show that it worked out to be fairly close. So once I had this scan in place, and by the way, I think I just downloaded this off Thingiverse or some kind of similar website. So I started with a control surface. Actually just going to see if I can update the color of this scan just to make it clearly distinguishable. Okay, that should do for now. So started with a control surface here. Again, I'm intending to model half of the product and then mirror later. Having this kind of just basic extruded control surface allows me to ensure that I can make the surface built later tangent to this. Then again, here what I started doing was some construction surfaces that I was intending to follow kind of the split along the controller. So kind of the point where a vertical line would be tangent, and that just helps later on as I'm building stuff out. So I'll just show another surface. So yeah, what I did was I made a construction surface capturing this kind of split line, and then another construction surface capturing this outside kind of boundary, and then did an intersection curve a little bit later on, and that gives me a nice 3D sketch which runs along the edge of the controller. So repeated that for this inside section of the handle. Just hide these ones. So yeah, I actually found that this handle doesn't have kind of like tangency lines that are, you know, on the same plane either side. Just as a side note, from investigating this, it looks like this handle section was injection molded with like a three-sided die. What I mean by that is there was a parting line kind of along here, a parting line that way, and then a parting line up here, and then like a central section there, which yeah just kind of means these three sections, you know, would have moved out after this was molded. Just good to have an understanding of how this may have been manufactured as you're going along. So okay, after I used those construction sketches to capture some of the boundary edges, which I didn't actually use immediately, I used them later on. Then I moved on to modeling the upper surface of the control pad. So first I did a boundary surface, and I found that this section is relatively flat. There's not too much curvature. I think generally with game controllers, the regions that have buttons and, you know, control sticks are kept flat, so that, you know, everything protrudes out like an even amount. Like you don't want one button sticking out way more than others. It just works functionally better if it's kept on a relatively flat surface. So yeah, with that in mind, modeled this first surface going across. Just kind of made an arbitrary choice of where I decided to terminate that. So actually it's probably worth me showing a bit more detail, yeah, because there is some kind of important stuff here. If this video ends up being a bit too long, I'll probably, yeah, break it into multiple parts. But yeah, this sketch that I have highlighted here with the curvature combs, I actually decided that I would do a single sketch to kind of capture the curvature of the entire upper section to the edge of the product. That way, I'm ensuring that if I'm using that to build the entirety of the upper surface, even if I do it in multiple sections, I should get nice curve, like continuity between the sections as I go along. Here, and just using a slightly different kind of cross section than I used at the start. And when I was modeling this, I was making planes to build off. So yeah, where I decided I wanted the first kind of surface to terminate, I would make a plane there, and then I would use a section view to come in and yeah, draw a curve which relatively closely matched you know, the information I was getting from the 3D scan. Okay, moving on. Okay, here I decided that this section in here is a little bit tricky because I'm kind of going from a curve in, you know, one direction, and that kind of gets wrapped around. So decided that would be a blend that I would tackle later on. So my approach was that I would model the relatively large areas, so the top surface of the controller, the back surface, and this handle, and then blend them together later on. So I decided it would be nice if I could kind of just model this entire section, which is essentially the remainder of the upper portion, and then I would cut away this region down here, which I don't want later on. Kind of going back to how I was doing it incorrectly before, trying to do too much in one go. This was just trying to capture that kind of overall upper curve transition. And one very useful technique with surfacing is that you can trim away what you don't want later on, and this just allows you to keep a nice kind of consistency or flow rather between the surfaces. So yeah, these are just things you play around with and pick up as you go along. But I can see here this allowed me to have a nice flow across these surfaces. And I did a similar thing up the top here. So had I tried to model this just kind of up to this boundary edge in one go, often what you get is, because you're trying to follow a relatively complex 3D curve, then you can get some buckling and some warping, especially at the edges and the corners of these surfaces. So if you extend it out and then later on come in and trim away what you don't want. So obviously with this surface trim tool, just demonstrate the sketch that was used. So this sketch was drawn on a two-dimensional surface and then projected down to trim away the region I don't want. You just get much nicer and cleaner surfaces this way. Especially like SolidWorks often gives you problems at the edges where you make surfaces. So if you can kind of trim away any bad edges later on, just gonna actually see if that was the case here. A little bit. So see how there's just like a little bit of wobbling here, but once that's trimmed away, then it becomes a nice surface at the trim line. Okay, so that was kind of the top section, and as I mentioned, I was just going to leave a bit to do a surface blend later on. So moving on, did a similar thing with the back. The back was a little bit more tricky from memory. Again, started with a control surface, which I was going to delete later on, but used that as an edge to build my first boundary surface. By the way, in most cases here, I'm using the boundary surface tool. I guess this whole video assumes you're like somewhat familiar with that tool. But another option, I like to add the surfacing ribbon up the top here. You can use the lofted surface, but boundary surface is a little bit more powerful sometimes. So here, I made a single surface kind of up to a point that I realized, okay, the curvature starts changing quite a bit from here, but up until this point, represented by this plane, it's more or less flat. Then from there, made a few construction surfaces, reference plane, sorry, confusing myself here. And here, I also built a large surface that captured the general curvature of this back section, but I overbuilt it, and the plan again was to trim away what I didn't want. And I mentioned before at the start of the model how I had used some reference planes to build control edges, which kind of capture the tangency control. And that's one of them here. To have a good appreciation of all this detail, yeah, you would need to step through this. I want to try be efficient and quick with this video, so apologies if I'm going a bit too fast. Some of these, well, most of these also have curvature combs turned on, which, yeah, makes it a bit tricky to see everything, but sorry, trying to stay on track here. Yeah, I built this back surface, and every time I'm building these surfaces with an adjacent surface, I'm at the bare minimum selecting that to be tangent to this face. Maybe in some cases curvature continuous to that face. And then I'll actually just go into this feature to, yeah, really demonstrate what's going on. So choosing my control lines in two directions. The first is the edge of this surface, highlighted here now. And the second is that control line, or sort of parting line or tangent line that I made earlier from reference surfaces. And then I'm using, in this case, 3 cross-sectional curves to drive the curvature across. And again, the way I made these curves was by making planes at the points I wanted them, and then doing a cross section of the scan and drawing, yeah, a control curve across like that, and yeah, doing that across multiple sections. So it is quite time consuming setting this up, and then it's also good to use the curvature combs, which are, you know, these yellow lines here, to make sure you have the kind of intended curvature you want. Because especially sometimes, you know, if you've got very many control points in your splines, your curve can look correct, but it's kind of curving in the wrong direction, or the way you don't want it. So one other important thing that I really should have mentioned earlier is, for all these curves, I'm using a style spline. So when I go to select a spline, instead of doing a regular spline, I select the style spline and go 1, 2, 3, and then right click and select. So that's the simplest style spline you can draw, with 3 control vertices. And you can adjust these here where you add more. But in general, for a style spline, the first kind of control vertice dictates tangency. So say I had another line that was like this, for example. If I make the first CV point collinear, it means that this is now tangent. And then if I make the second CV point collinear again, this is now curvature continuous. So just keep in mind that if you want a style spline that is curvature continuous at 2 ends, you need 5 CV points, because you would have to have 2 that are, yeah, collinear with each other, kind of like this. So really, yeah, again, this is kind of assuming that you are somewhat familiar with a lot of this stuff. Yeah, apologies if this is just going too quickly. Yeah. Okay, but yeah, so in this case, this red line here, I know that I want these surfaces to be tangent in the y-axis. I can see that in the bottom left corner of my axis, kind of the vertical axis. So what I did was I made this line down here, this control line, vertical. And then down here I had selected the style spline and an equal curvature relationship with a control line on this surface. Sorry, just realizing how much there actually is for me to go through now. But yeah, what I mean by that line, control line on this surface, is a line here. So just kind of realized I probably need to also show how I made this control line here. Okay, once I'd created this plane, so just rolling back the model a little bit. Once I'd created this plane and I decided that on this plane I wanted a control curve going across, then I made a 3D sketch, and in that 3D sketch I did a convert entities and I did an intersection curve between the plane I had created and the previous surface that I was intending to build off. And that automatically creates a line which sits on this previous surface, which I can then use when I'm creating a new style spline to set it curvature equal curvature. So this is this is a way that you can ensure that these kind of cross section guiding curves have curvature continuity with the surface you're choosing. If you omit these, you just don't necessarily get the intended control you want. You know, you can imagine there's essentially infinite ways you could blend the edge of this surface to this red line. So you need to draw in something to give SolidWorks an idea of what you want. But you also need to make sure that what you're drawing in, these curves you're drawing in, at least across the flat planes you're drawing them on, have the same kind of curvature at the transition. So yeah, I hope that makes sense. Sorry, I just really realizing there's a lot to kind of unpack maybe for, beginner to intermediates. Yeah, and essentially then trimming away what I'd made. So keep in mind here that I didn't figure out all of this on the first go. Sometimes you come in and you play around and then you go back and change something. For example, I found out that 3 cross-sectional guide curves worked okay here, but I'm sure when I was playing around with this, maybe I experimented with 1 or 2 or even 4 and then went back to 3, so on and so forth. Anyway, powering through for the sake of efficiency and time. Actually, just going to hide these again. So just actually a quick recap of where we're at up until this point. So I'd made the top surface of the controller and the back surface, and I'd left a section where I was going to blend that with the handle a bit later on. And this might seem like a lot of effort, but yeah, at the time that I'm doing this, I'm also using the zebra stripe tool just to make sure that everything is reasonable and there's no big breaks in tangency. And also the curvature tool as well, more or less in between each major feature to make sure that my intention of good quality surfaces is being achieved. Here, so I might speed up a little bit here. I decided that this handle is more or less, a deformed cylindrical section. So I'm actually just going to change the transparency of this, make everything a bit easier. Yeah, I decided, okay, I'll just model this in a kind of surface body that is, roughly a cylinder. I knew I would need multiple planes to build my 2D guide sketches off. And a nice trick you can do is that instead of, going through and adjusting planes and repositioning them each time, you can just draw a 2D sketch and extrude that out to give these surfaces, which I later use to draw sketches on. You can use these as you would use a plane. It just really helps when you want to quickly get different kind of angles to build off. Okay, just hide that. And again, a similar thing here, a plane, flat plane that kind of runs down the middle of the handle, which I would use to build guide curves, guide sketches on. Yeah, so here this was a large surface feature, so doing a lot in it, but kind of worked out okay. Yeah, I actually just go into this quickly. So here I have 1, 2, 3, 4 kind of rings in one direction, which are represented by the blue, and then 1, 2, 3, 4 lines, so kind of top, bottom, left, right, in the purple to guide this. And it's difficult to see what's going on because the curvature combs are turned on for each one. So just going to roll it back a little bit and I'll kind of explain one and then you'll get an idea for the rest of them. So starting at the top, one of the flat planes that I wanted to draw a control sketch on, I would do a cross section at that point. And then come in and start my sketch. And I wanted my sketch to follow the edge of the STL cross section, or the scan of the controller. And it's important, or it's very useful to have the curvature combs turned on when you're doing this, so you can make sure that your design intent is achieved. And more specifically, what I mean by that is that this curve, I know I want it to be kind of concave the whole way around. But sometimes if you don't have these curvature combs turned on, you could have little convex points that you wouldn't otherwise notice. But the curvature comb tools allow you to evaluate that, because you could determine the transition between convex and concave by a cross. So if the curves were like crossing through the actual blue sketch, then that would indicate that. But because this is all above the blue sketch, I know that it's all concave. So I'm achieving what I want. And again, I just did similar one on the bottom here to line it all up. One thing I found that SolidWorks does, I'm not exactly sure why, but if you look at these curvature combs, for curvature continuity, there shouldn't be a spike here or a gap. It should be a smooth transition. But it actually is. It's just a different scale, depending on, because these are in different sketches. So I'm in this sketch with the bottom curve now, and if I actually just go convert entities and convert this top one, I'm just going to turn on the show curvature. We can actually see that the curvature is continuous. Not on this side, because I actually don't necessarily want curvature continuity. I just want tangent continuity, which just means that they end at the same point. But just keep that in mind. That's something that took me a little bit of time to figure out. So more or less, I went through and I built multiple cross-section guides as references, and then extruded this whole cylindrical section in one go. Sorry, not extruded. Use the boundary surface to build it in one go. Okay, jumping through to the next section. So here is where I started, blending the handle cylindrical section to the previous surfaces that I'd made before. Again, I just built some flat surfaces that I was going to use to draw reference sketches on. So I actually found that later on this gap was a bit too small for me to get a nice blend transition. Sometimes you might find that your surfaces might just be like a little bit too off from their kind of intended regions that they should be sitting in. I trimmed back the kind of gap a little bit more, and this model has a few surfaces that I'd built and later didn't actually use and just deleted them later on. So could go back and tidy it up a bit. But getting into the blend. So, okay, what I found here, and I'm not sure, how common this method is, but if I go into this boundary surface, I've just actually used two curves in one direction, which are both the edges of the surfaces that I want to blend between, and I don't have any guiding curves between them. What I was finding was that when I was drawing guiding curves, even if I used like an intersection curve on each plane and then drew a style spline with 5 CV points in between and made it curvature continuous, I just wasn't getting a nice smooth surface in between. So I actually just kind of artificially set the limits of where I want this blending surface to terminate. And the way I did that was with a simple 3D sketch. So I just did a 3D sketch and did some points which were coincident to the edges. Set them at specific distances. Could go back and change it later on. And just showing how you would select that in here. So selection manager. When I select the edge I want, before I click OK, I get these white points that pop up, and if I drag them to my 3D sketch points, they kind of snap in to those points and snap in there. It kind of goes orange when it's going over. Then I hit OK, then selection manager again, and select the next one. Drag the point to the 3D sketch point. Go in like that, and then OK. If you get something like this, just right click one of them and say flip connectors, and then for both of them, I'm choosing tangency to face. I'm just gonna undo all that, but that's how I built a lot of these blending surfaces. If someone knows if that's kind of acceptable or has any comments or feedback on that, please let me know in the comments below. This one didn't actually need to do that because I already had the edge in the other direction I wanted to use, and then that large control line from very early on in the model. This was just a construction surface again to build this, to build this large blend here. So this one I will just talk about briefly, and it's actually given me a small error. I'll just see if I can fix that. So sometimes, seemingly for no reason, one of my equal curvature relationships just seems to fail, but if I delete it and then re-add it, it seems to be happy again. But because this section had quite, a specific, blending radius or blending form, I found that I needed to add some intermediate guiding curves. So yeah, this is just equal curvature to a curve on this construction surface, and then equal curvature to another curve on this previous surface. So I got, yeah, two equal curvature and two tangencies. And I found that experimenting with these CVs, so like, you know, dragging them around, dramatically changed the kind of what I was achieving with the surface. So just, okay, exit out of this. Yeah, what I mean by that is how I would play around with those CVs dramatically changed the curvature flow that I was assessing with the zebra stripes. And that is like a little bit tedious, but yeah, I'm just, you know, because it's a little bit of trial and error. You would go in, and in this case I had two kind of guiding curves and play around with them and change it a little bit, play around with it more. So yeah, can be quite time consuming doing that. And I kind of just got to a point where, okay, this is good enough, this sort of surface flow, but yeah, don't want to drive myself crazy to try get it absolutely 100% perfect. But yeah, I then had kind of blended at least the top section of the top of the controller to the handle, and bit of wobbles here with the zebra stripes. I'm sure I could go back and, you know, fine tune it to get them a little bit better. But overall, reasonably happy with the transition around here. And then, yeah, deleting away any construction surfaces that I'd used. So moving on to the blend on the back or bottom side. This was fairly difficult for me to get well, to make it reasonable. Definitely didn't get it perfect, but yeah, quite happy with the transition here, like with the zebra stripes giving a nice flow and kind of indicating where the tightest kind of curve runs. When using the zebra stripes, it's also important to switch between vertical and horizontal. And yeah, again, not perfect, some wobbles, but overall not too bad. But yeah, if you want to switch between vertical and horizontal pretty often to, yeah, make sure you're getting exactly what you want. So going up to the first section, turning off the zebra stripes. Oh, sorry, I went too far. Okay, for now, I'm actually just going to hide my STL scan. Just a bit easier on the eyes to explain everything. So actually, in this case, yeah, I did draw some flat planes, and I think my intention was, yeah, to make some intersection curves on them and then use them to build a boundary surface. But yeah, I didn't even actually use them in the end. So I just kind of left these edges floating in the sort of second direction, and just used edges in the first direction, terminated, you know, either by like 3D sketch points or some reference feature or reference sketch. So the reason I think this works and gives good results is because you're not constraining this edge. You're kind of just letting SolidWorks figure out what it wants to do. And I was selecting curvature to face at the intersection points. And yeah, I just found that gave me a nice result. So looking at the zebra stripes, yeah, that kind of just gave like a nice continuity between these surfaces. Both with the zebra stripes and the curvature tool. And of course, if I am doing it this way, I'm not explicitly controlling, you know, these edges, but I'm directing it enough that it stays reasonably close to the model, and yeah, giving me a result I'm happy with. there looks like I just built a construction surface. And yeah, here another boundary surface blend. So in this case, using for the second direction, the edge of that surface I just made, and then the edge of this upper section. And it looks like I needed to come in and add a third curve to help guide it a bit later on. Generally, you kind of want to start as simple as possible with, you know, minimal guide curves, see how you go, and then add complexity as you need to. I think actually there's one more thing I wanted to discuss in this first one. So can see here that this tangent length represents kind of how intensely the surface comes off tangent to the control one. So can also like drag this slider, or you can explicitly put a value in there. And in this case, that allowed me to adjust kind of where the adjust the form and the curvature of this blend. So that actually was a bit of control I had over this to get it to match my my scan of the controller. So yeah, just going to undo that. Going back down here, again, much the same. Yeah, so you can also, if you make sure apply to all is ticked off, then you kind of get these 4 arrows at each point, which you can use to drag and slide. It's kind of useful, or maybe even crucial, to have the zebra stripes turned on when you're doing this to sort of see how the curvature is changing. Obviously, zebra stripes that get squished together more or less represent tighter curvature in that region, and then moving around, kind of just manipulating the view. And yeah, that kind of becomes like a little bit sort of tedious and almost artistic at this point. But yeah, just keep in mind that that is a tool at your disposal, because in all these cases I'm not using curves in the second direction, so this is a way of controlling that form. And again, yeah, then just like another blend between them, using tangency to face at all surface intersection points. And final one down there. So yeah, this whole time I've actually had the display set to edges turned off. But yeah, if I turn the edges on, it gives a depiction of each separate surface I've used to build up this model. Perhaps on the back I could have used fewer, but yeah, this is just kind of what I ended up with after playing around. Producing the handle tip. Just go into this. So I mentioned in the first model that I made that was incorrect, I'd done it in a way where I end up with a kind of point where the surface is collapsing on itself. SolidWorks, or you know, NURBS surfaces generally like 4 sides. So what I'd done is trimmed away this section, because you know this kind of just gives one edge or one side. Trimmed it back a little bit first, and then yeah, trimmed away to give multiple edges. So I'll just use these straight lines to trim away this section. Again, then just another plane or flat surface to draw control sketches on. And down here, I actually found that the surface fill tool was working a bit better for me. So yeah, this is another point that I could improve my skills and my modeling on. But yeah, I used you know, 3 of the edges that were produced from the surface trim, and then this kind of just general tangency 3D spline going around, and then yeah, some control curves sort of in each direction perpendicular to each other to build this up. I do remember I had a little bit of trouble down here, and I believe it's still not totally perfect. Yeah, like a little bit of wobbling there, which don't really want. But overall not too bad. And yeah, just going to power through the rest of this now quickly. So top surfaces up here were fairly straightforward. So it's going to turn these edges off again. Just making some reference planes, and then yeah, reference planes again, and then a surface loft around here to kind of capture this chamfered edge or beveled edge, and yeah, again, so these have various, you know, cross-sectional guides to yeah, guide it round as I'm going. A control surface up here, and then looks like I used the surface fill again to build this up. So in this case here, I used the surface fill tool because this is a 3-sided surface. So as I mentioned before, if you're using like the boundary surface tool or a lofted surface tool, if you use three edges, you get a degenerate point where the surface is collapsing on itself. It's essentially assuming that the 4th edge is infinitely small. The surface fill tool can deal with that because this kind of internally in SolidWorks overbuilds the surface and trims it back. Sometimes with the surface fill tool it does funny stuff, but again you can come in and add guide curves. So yeah, more or less did that here. This surface doesn't need to be kind of tangent or curvature continuous because we actually do have a sharp edge here that we add a fillet to later. Just knitting those together. Okay, gonna hide my scan again. Okay, so there's a small fillet at the transition here, which, you know, there's multiple ways to go about this, but I modeled it in with a sharp edge, and then, you know, swept the surface cylinder around and trimmed away what I didn't want, and then, yeah, did a boundary surface between them, curvature continuous, or tangency continuous to get the fillet. You don't have to do this at this step. It depends, you know, what your kind of intention is. You could make this less solid later on and then add this fillet in here, but yeah, I just decided to do it here. Add that fillet in. From this point, I did some sketch projections using the split line tool to cut away regions where the trigger buttons would be. These trigger buttons are not modeled super accurately, but yeah, I did kind of just build them up off sketches using boundary surface, quite a few, and then knitting those surfaces together and making a solid, adding some fillets. Kind of at this model, I was just, you know, rushing through and doing a quick dirty job, but it does make you appreciate, you know, even small parts like these triggers, like quite a bit of design and manufacturing effort goes into this stuff. Okay, a couple faces are missing there. So at this point, I thickened the model. Yeah, so I would have knitted everything together, and then yeah, added a surface plane to kind of cap off this end, so I could knit and make a solid, and then shelled everything. So I actually found in this shell tool, I was having some issues. Like I could produce a 1 millimeter thick shell and I could produce a 2 millimeter thick shell, but for some reason I couldn't produce a 1.5 millimeter thick shell. I think that's because this small fillet I created before was giving me some problems. So yeah, we'd have to go back and kind of play with that. Maybe do that fillet a bit later on to make this more robust. And obviously, also at this point, I never really mentioned this, but I'm not actually trying to intend to design this thing to be manufacture ready, just more or less capture the overall form and the shape. So obviously there's a lot of design effort that goes inside this controller to, fit and house all the electronics. But this is more just focused on the outer form using surfacing techniques. Yeah, splitting everything up into the multiple bodies, the way they're kind of depicted on the product in the real world. Yeah, splitting this handle away from the body. The way I did that was made a 3D sketch that was laid on this surface around here. Yeah, I think then actually extended that surface out from that 3D sketch and then filled in the central part and used that to split these bodies. Not sure if that was the best way, but it was a kind of quick way that worked at the time. Then, mirroring everything over to get the full body. Then the control pad, obviously, because the buttons aren't symmetric, have to do that after the mirroring occurs. But at this point, it's more, finished the sort of surfacing features and just dealing with solid body stuff. So yeah, just produced a plane or a flat plane to sketch on, and cut away openings for everything. Then just started producing solid bodies, and yeah, this was relatively simple at this point. Yeah, just adding fillets, going through doing a bit of a loft or a blend between where the control pads are. So yeah, produced a flat surface, according to my 3D scan. 3D scan, if I have edges turned on, shows like all the edges of the facet, so only real way to look at it is with the edges turned off. But yeah, produced a flat surface there to represent that, and then lofted from there. Or did I? A boundary surface from there, yeah, to the main body. And yeah, if you are interested in this, I encourage you to go through my model and scrutinize everything. And if you do choose to purchase my model, yeah, thank you very much for the support. This took me quite a while to develop this model, but I do enjoy doing this stuff. So for the most part, yeah, it was fun. But yeah, I'm just going to kind of scroll to the end now, and at this point just went through and added graphics. In some cases just did some split lines to split up sections that have different appearances and whatnot. And yeah, that is essentially a very quick, very rough overview of how I modeled this. Just going to hide some of these sketches. And again, if I turn on some of the evaluation tools like the zebra stripes, they kind of have a bit less meaning at this point. Once you've got all the the solid bodies, they're more useful when you're just dealing with the surface bodies. But yeah, kind of depict the light reflection, and overall, I'm really happy with this. It was like I learned a lot doing this. Yeah, if this were manufactured, I think it would look alright. The actual Nintendo Switch controller does have these sort of soft touch textures, which is just like a very fine kind of rough texture, which means that they're not super glossy and it's more forgiving with the way it kind of like diffuses the way light reflects off it. So I think, you know, this in terms of the surface quality here, this would be close to being okay. Generally, SolidWorks is, you know, this kind of roughly at the limits of, you know, what SolidWorks is intended for. I think, you know, Creo or NX, Siemens NX, you know, more tailored to doing this kind of surface, product surfacing. And then again here, the surface curvature. But yeah, if you've learned anything from this video, yeah, please drop a like and subscribe. It really helps me out with my channel. And yeah, any feedback is much appreciated. And yeah, I might just actually do a quick evaluate if I can find it. See how many features there are. Where is it? Performance evaluation. So yeah, 330 features. Yeah, that shell and some surface fills were taking quite a bit of time there. But yeah, without rambling on too much more, thanks for watching the video this far through if you have. Okay, bye.